Most of you are aware at this point, my name is Samuel George. I am a recently graduated game developer and have been working with the Unity game engine for about 5 years. I saw a lot of questions about how did I get started, and was it difficult, was it easy, what was the learning curve, things like that. So I was thinking I'd start today with just a little bit of background on how I learned to use the Unity system, and that was at a place called the Gazalea Neuroscape Research Facility. So my job there as a volunteer was to use Unity to develop both research and diagnostic grade programs that could be used with the human brain. So the first project I worked on was something called the Body Brain Trainer, and my job was pretty minimal, store this data, move this character from here to there, whatever. And that was a really good place to start. It requires no additional functions besides the base monobehaviors in Unity. So that was a good introduction, but I'm sure you've learned pretty easy to overcome and be interested in learning something slightly more advanced. So at that point, I took several free courses online that taught me how to integrate the Connect V2 motion capture system with Windows and therefore with Unity. The main issue there being that, well, we're a brain lab, we don't know anything about motion. So then I had to work with a team of physiologists, neuropsychologists, neurologists, etc., to help design this pretty large-scale program. And in fact, I was in charge by the end of this with the motion capture systems for the breaks in between the most difficult levels. Now, the main concept behind this program was to train the brain and body at the same time. And I'd love to demonstrate this. Unfortunately, most of that work is covered by more contracts than I knew I'd ever have to sign. So I'll try and describe it to my best ability, but try and bear with me. So the main concept is there are 3 well-founded neurological tests or activities you can do that are known to strengthen the brain. None of the lumosity or whatever. That was a 4-letter word at the lab. So what we did was pattern recognition, object identification, and pattern memorization. And the way we implemented this was by splitting into 3 levels, 1 task per level, and then splitting those into additional difficulties. Personal favorite was where you had to watch these rings light up. They would move in a way you couldn't actually see them, so you couldn't track the patterns, and then you'd have to hit them in the same order. I could not pass that level, and I designed it. So what that did was it caused the brain to go into System 1 or slow thinking, which is how the brain does error checking when you're actually trying to process information, and then required a physiological response, System 2 thinking, rapid rote memorization, things you know how to do from everyday activities like picking up a pencil. And what we showed over time was that when people engaged with this program for a minimum of 10 hours a week, we actually improved on the standard rates of cognition improvement and physiological improvement. So this also showed that there is a sustained link between the brain and the body. They are not separate entities. We ended up also bringing sleep studies into this. We brought coordination studies, brain scans, etc., which fed into my next project at the lab, which was the Glass Brain Project. Now, while I was not involved in the primary development of the systems that rendered the brain, I did work with the Oculus from its first edition onward in order to make this a more usable diagnostic tool. I think most doctors would find it rather difficult to try and click around on this program that had no intuitive user interface, which is something that the Flappy Bird demo covered very nicely. So the Glass Brain Project was a particularly interesting one. What we did there is we would put, are you guys familiar with what an EEG is? A little bit. Essentially what it is capturing the electrical signals passing through your brain. And what we did with that was used a well-established equation, the Granger causality equation, and could establish where in the brain a signal was originating and terminating. We then fed that data through a programming language called R, which is a statistical analysis language, and then converted it into Unity units. We were then able to scan participants' brains into Unity, make our equations work such that we could identify primary nerve bundles in the brain, and then would put this system that captures the electrical signals from their brain and displayed it on screen as those signals were firing. And that was an utterly fascinating project, but by far one of the most challenging things I've ever done. Now, as I said before, my primary role was in integrating external services, which is something that I have wildly underestimated the commonality of for game development. So at that time, I had to learn how to work with the Oculus SDK 1, which was just so slow, but effective. It got the job done, coupled with something called the Leap Motion Controller, which was a very interesting device, very similar to the Kinect, but only registers your hands. And so by the end of this development period, we had a program where we could put an Oculus on a doctor's head with the Leap Motion Controller attached. They could view their patient's brain working electrically as it was working. So you could give the patient a test and say, okay, well, there's noted, decreases in activity here, increases over there, what have you. And that could be of major benefit. But as I said, it also required an intuitive interface. Well, what do you use every day? Your hands. Exactly. So with the Leap Motion Controller, I developed a system where your left hand could be brought up to here, and it would bring up a virtual menu that you could then interact with your other fingers. That system was incredibly intuitive based on our focus groups. The only real issue with it was that a lot of the systems we were using at the time were then discontinued, which is something I warn everyone to realize will happen at some point. You may think the system is not going to fail, but it can happen, unfortunately. And that was the last project I worked on there. And I ended up coming back up here to go to Evergreen to actually get a Bachelor's of Science in Computer Sciences, because you're not getting hired anywhere without one or without equivalent work experience. So up here, I continued taking these external courses in game development specifically, and studied computer sciences just in a raw form in school. And this gave me the opportunity to try and work in the more advanced systems that I was conceiving of outside of class. And it was actually fairly interesting to combine my previous work at the lab with my work here at the school, because obviously there was a significant change in my ability between, each facility. And so I wanted to bring up the one thing I really can show off, and that's the Chronos Project. A brief overview for it is that it's a game designed to make players not just think about their location in space, but also think about their location in time. If you would, you could think of perhaps Counter-Strike or Fortnite or some other pretty wild, high-energy game, and then disperse one level into 6 copies with varying rates of time occurring. This actually was way easier to program than I thought, which was a pleasant surprise. And this is definitely something that was covered in the tutorial that you guys are currently working with. Planning. Planning is the sole key to this. I actually did not plan this properly. I assigned 8 weeks for the time system and 2 weeks for the terrain. The time system took 2 hours. The terrain took 10 weeks. And so that's a little bit of what I'm going to cover here on this project. So it starts with the terrain system. So this is something that you want to really familiarize yourself with. This is a function chart. Now, I have made several important changes to the program since I've made this, so it's out of date. And I'd be happy to provide a new one if you guys want. It's coming out really blurry. But essentially what you're seeing here are the different execution states required to generate a highly randomized terrain. So the way this came about was when my friend and I were thinking, we play a lot of games and you play the same multiplayer level over and over and over. Eventually you just memorize it, or people get bored of that level just because they've played it 1,000 times before. Why would you do the same thing 10,000 times when you've done it 1,000 already? So we thought, okay, what if we could, at the moment of loading a level, completely generate every aspect of it from scratch? And that's what this system became. And the real reason that we worked so much on this particular system, like I said, it did take 10 weeks to finish, of working 7 days a week, was because it used every single thing we learned in class. And that is also a fundamental to programming. If you can find a way to link two concepts, you, generally speaking, have just outdone all of your competitors. Because you're going to have something that is based off of a well-founded idea, another well-founded idea, and the link that you put between the two. So this, in particular, had to do with something called threading. I don't know if that's come up in your learning so far, but it is something that whose usefulness cannot be understated. So threading here meant that while the level by itself, when running on a single process on your computer, would take an hour to load, literally an hour to start the game. Once we added multi-threading to this, and it ran on about 10 threads, it took about 3.2 seconds. Multi-threading is going to be something you want to cover extensively before moving on to advanced projects, especially when it comes to generation. So moving on from this particular diagram, the terrain itself, while not beautiful at the moment because I'm not a shader programmer, will come out like this. Now, the key to this is that the moment I clicked the play button in my Unity editor, it generated something that had never been seen before. The statistical chance of this showing up more than once, I think it's per 5,000 executions, is something like 1 in 50,000. And the key to that is no one can get bored of it. Downside, if you find a level you really like, it was therefore impossible to play it again. So we have corrected for that. We did make it so you could save, which actually gave us full marks for the project. But this was one of the most complex things I've worked on, and the reason for that, other than the more advanced systems required to make it work, was the pure mathematics behind it. So that's the, got a question?
This is a normalized sound.
Entirely correct. Good call, yes. It's all based off of a Perlin noise function, which generates a two-dimensional image, essentially looking like clouds, and then is mathematically altered so that each pixel, whether black or white, or somewhere in between, would then equate to some altitude on the y-axis. Now that was a fascinating program to write. However, as I said before, planning is the single most important thing when it comes to programming, and I did not plan this well. It is the only operational system in the Chronos Project, but certainly one to be content with. Now, since then, I haven't really worked on the Chronos Project as much because, as you may or may not know, do you guys work with Jay Balakrishnan? He comes into classes sometimes. Yeah?
Yes.
Okay. So I work on a project with Jay called Project Projector. And that's, while I don't have a good example of that because it's so early in its development cycle, it would be easiest to say that we have found a way where we can convert English text to computer code and therefore automatically generated 3D films.
Wait, can you say that again?
Yes. So we found a way to take plain English text, convert it into computer code, so it converts into a language that I created called HLML, or Hollywood Lingo Markup Text, or Markup Language. Then that...
So it'll act it out.
It will. It will literally, if you give it the right series of instructions, act out essentially anything that can be animated. We do this through something called, and this might be interesting to anyone who's mathematically inclined, the inverse kinematic animation system. Now, there is, in my view, some controversy surrounding IK animations. I'm sure some of you here have played the last Mass Effect game, Mass Effect Andromeda, which had those miserable animation failures. That's an example of how not to use inverse kinematics for dynamically generated animations. The key being, if they had actually hand animated each scene in that game, it would have taken them a couple hundred years to finish. So IK is definitely something I recommend looking into in the future. But I also say, animate what you can because IK is not there yet. But yeah, so the Project Projector system is currently at a state where we can get characters to move on stage. We can get them picking up and placing objects dynamically through the IK system. We can get characters moving at any speed, so if you say walks quickly, it's going to have an entirely different result than saying walked. So while that's all fine and dandy, we have run into several problems, like how do we store that many potentially usable assets? I mean, I can't just say, well, unless it's aliens versus cowboys, I suppose. I can't say let's have a bunch of ray guns in a Western epic. You can't generate that because that wouldn't make any sense. So now it's a matter of how do we actually organize this system such that it can handle immense amounts of data from outside of the main program and then generate the same product we have right now. And this is a problem we have not solved yet. But it's certainly been a very interesting process, and most of it has had to do with programmatic interpretation, which is another key point I wanted to bring up today in terms of anyone who might be wanting to advance in a career in software development. There are two primary ways of using code. There's the interpreted code, like my markup language, which you will find in HTML. You'd find it in Python, if anyone's used Python. That's an interpreted language. And I believe Haskell is an interpreted language as well. Now, however, C# is a compiled language, and I actually tend to prefer compiled languages for performance reasons. When you have a compiled language, once that code is in place, it is fixed. You are not going to decompile and recompile during runtime. So there are some drawbacks to it. If I'm writing a Python program and I wanted to make a quick change to what it's doing, I could halt the interpreter, make a change, and then let the interpreter continue. Very simple. C# can't do that. But it's important to note the difference between the two for things like game development because you need to consider every aspect of what could be affecting the performance of your game, which is what I'm currently working on in my professional life, is how do I manage my performance? And that has to be, other than planning, the second most important aspect of game development is memory management. And that's true about almost any type of programming. There are a few cases where you just don't need to worry about it. I have these C# codes that I wrote on my home server, and all it does is send me emails throughout the day giving me server statuses, weather updates, etc. Not too concerned with how much memory those are using. But when it comes to writing something like this, with the multi-threaded terrain generation and heavy processing of mathematics, memory management is going to be one of the highest priorities you have. Now, multi-threading is one way of handling that. Other ways of handling it are optimizing functions, reducing class counts, using the Singleton pattern that you guys learned in your demo tutorial, using object pooling would be another great example of how you could increase memory efficiency. And I know you guys are more or less familiar with that one. So that's sort of the major set of projects that I've worked on over the last 5 years. There's Project Projector, BBT, Glassbrain, and Chronos. I'd say out of all of those, probably Project Projector is my favorite one, simply because it's provided so many different small challenges that I have not had a single boring day in the last 9 months with respect to that. So moving from there, it was interesting to come back to a Unity Learn experience, which I had not done really much at all. I'd taken a couple of those courses when Unity was still in version 4, which I was reading some of the questions, and I thought, I remember in version 4, they didn't even have a button to show the Animator window. You actually had to go through and find all the different components for it and add them to the asset list. But I lost my train of thought on that one, but yeah, so memory efficiency, working on these projects, it was interesting coming back to the Unity Learn tutorials because I thought, you know, oh, what am I going to see in this that I haven't seen before? Well, the Monobehaviour Singleton pattern was something I actually hadn't come across a single time in 5 years. For 5 years, I had thought to myself, how could I possibly get a Singleton instance in a Monobehaviour class? It just doesn't seem possible to me. And I swear every time I have said that exact phrase, it doesn't seem possible to me, I have proven myself wrong. Coming back and being able to learn something new from that was just a really enlightening experience. As much as this might sound odd to say, I am always really happy when I find out I didn't know something about programming or game development. It really inspires me to keep working, keep learning, keep up to date with new technologies. There's never a point where one could genuinely say that they could stop learning and be fine, especially in game development. That would be as crazy as having uttered, there are no more inventions to invent, and so we should close the patent office. Same concept. Doesn't work. So while I was working on this, and you guys, they have access to the documentation I wrote up?
Yes, they do.
Okay. So I did write up a set of documents that just sort of covered a number of my steps, not all of them, but the most important steps that resulted in some major change to the program. A lot of people will say you have to get way into the granularity for your development notes. I personally disagree with that. Unless it made a major change and had some sort of system level effect, then I'm probably not going to make a note of it, because it's, that could be, I'm not going to change a 0 to a 1 because I just needed it to start at 1 for a while. I'm not going to write that down because I'm going to put a comment in there and say change this back to 0. Now, I don't know if you guys have gone over those documents at all, but this is more or less what my kind of notes would look like.
They have not looked at them yet.
Okay.
And that's not their fault. It's me. I didn't get them published to their server folder.
Oh, okay.
Like a couple days ago.
Well,
If you want to zoom in,
yeah, that's what I'm trying to do.
if you do Command plus, you're just on the document. Command plus. There we go. That works.
Yeah. So this is a pretty generic look at what I'd use as a development log. I cannot stress how important the development log is. There have been 4, maybe 5 occasions in the last week where I've had to go back into my notes to figure out exactly where I screwed up the whole thing. And that was also something to get used to saying. But it's pretty basic. I prefer to delineate between, so I have OpenBird here on Multisprite in the editor window. Now that might seem like an unremarkable step to take, but it was the steps that came after it that were that altered the overall system of my program. And so that was something that seemed worth writing down, despite the fact that the first point on it is completely innocuous. And then dragging it into the hierarchy window, also innocuous, but it's important to note that it added n number of sprites to my project, the project window, and only added 1 to the hierarchy. And then just doing basic, so I also differentiate between numbers, dashes, and dots, which for me, because I'm a visual person, they simply mean that I'm working with a slightly different system, or it's a repeat of something in this case where, adding grass then didn't seem as important it didn't seem as important because I had just added a sprite previously and I didn't need to relist every single step of doing it. But I did want to note that it was done. I wanted to note what I did with it. That way, if I needed to do it again, I could just come back to it. Yes?
So, coding program is a very mathematical kind of feel.
Yes.
And if you want to get into the game design industry, you're basically going to
Yes.
As someone who really wants to be a game developer but does not like math in the slightest, do you think there's any possibility of me being able to learn?
Absolutely.
You think so?
So I am not a mathematics person by nature at all. And one of the single greatest bits of wisdom, let's call it, that I ever received was from a wine store owner in San Francisco where I moved here from. He's been a longtime family friend, but he's a Harvard mathematician with a PhD. And he said, Sam, there are two types of mathematicians, those who get the math and those who don't. And I said, what do you mean? And he said, when you go back to college, you'll understand. Well, I wish he had just told me. That was way too cryptic. The way I've seen it is, or experienced it, I should say, is more in, while I don't get the pure math on paper, when I'm taking an exam or something, I wouldn't say intuitively, but when I'm working with mathematical systems and programming, it's actually much clearer. It's like punching into a calculator for me. I'm less nervous about it, I think. But yes, absolutely. So my animation system for Project Projector, not a single formula in that. The whole thing is handled by the background script. So fortunately, there are different positions in game development. You could be an interactions developer. Worst case scenario, I think you're dealing with multiplication there. And it's going to be for, buy 2 times this many items worth of this much money. If you go into something more like the terrain generation system I was talking about, which would be a game systems programmer job, you're going to be dealing with pretty advanced mathematics, trigonometry, vector calculus, things like that. But there is a broad spectrum of heavy math, light math jobs in game development, so not a concern.
All right.
Yeah, really it's the programming that matters. Yeah. And like I said, and you'll note, actually, speaking of math, there's none in this, as far as I recall. But moving forward on the notes here, where'd we go? Here we go. Testing. This is something that I actually wish I had started doing sooner in my learning. And in fact, it is Jay who's really prompted me to learn more about quality assurance testing, QA. So every single step of this demo, I stopped, look at how my assets were set up without looking at the actual tutorial window, and then ran a test. Could it do what was described? And that's parameter-based testing. That is, so there's a couple of ways you can do it. You can do something called unit testing, which is using code to test your code. That is very useful in the mathematics, for example. But for something like this, it's actually far easier and in my opinion, more effective to actually test by simply putting in debug statements, debug.log, going into play mode and seeing if things turn out the way you're expecting them to. It's not necessary to create, 4 more classes to test whether or not the bird can flap its wings. It's just, that would be overkill. Since this was a learn concept, I also wanted to include something I learned to do when I was back at Evergreen in upper division computer sciences courses. And it wasn't too beneficial when I first started doing it, but it became very beneficial as I moved into things like Chronos, into things like Project Projector. Code concepts, small snippet right at the beginning of a section where you're starting a new system. You don't have to do it when you're modifying a system or rewriting it or refactoring it, unless there's a major change in the refactor. But with this, it's been important for me to record what it is that I'm trying to do with my script. So in this case, I was covering the concepts of class scope variables, that is, variables contained within a class but not within a function. Stopping via Boolean, which is game logic control. Accessing events using Unity functions. So that one is actually trickier than I thought. There are definitely times where I've thought, oh, well, I'm just going to create this public class and throw a couple of Unity functions in there. Fun fact, if you're not inheriting from Monobehaviour, you're not using those functions. You can't do it. Which I actually learned recently because I thought, oh, well, I'll just do this like they did in the demo, and nope, can't do it. I also will note, since this is a learn and I'm coming back to something at this level, I put some personal notes in there that I thought might be useful for you guys. So I felt like while the narrator did a very good job of teaching the concepts he did, there were a few not advanced but extraordinarily useful concepts such as require component, which I thought I'd touch on briefly while I was here. Require component, so say you were working with the bird and you wanted to control its animator, and for whatever reason the animator is not actually on the bird. Well, you can require component animator, and if it's not on there, it will add it and then throw an error message saying there's now a blank animator on here. But per a lot of the questions, it helps solve some of the debugging problems that some people were having, or just it's another method for it for those who asked. Because then I can say, oh, well, it's simply I forgot to drag this component onto this and assign the animation states to it. And it was way faster to figure it out that way than, say, looking through my entire project and wondering where it went. So require component is a simple but powerful tool in the Unity system. Again, I made a note here. He did a good job of explaining IEnumerators, or coroutines, pardon. I personally find them more useful than he does. And so I leave it up to you. It's sort of a 50-50 debate. I don't think the memory overhead, as I was saying, memory management is super important. I don't think the overhead is too much for this project. I think it would have been acceptable to have a coroutine run all the timed functions. Let's see if there was... Yeah, other than that, so yeah, now... How many people here have had an issue with the Animator system or the animation windows? Because those came up a lot. Would it be useful if I covered some of that just while I'm here? Because I did do some digging in there and just didn't have time to put it in my answers that I turned in. Yeah, okay. Is that all right? Yeah, okay. So the first thing that I noticed was that a lot of people couldn't find it. And I will completely agree here. It's a nightmare to find the windows in Unity sometimes. It just is. So the key is that in Unity, which I think, do we have that over here?
Yes. So resources are on the desktop.
Ah, here we go.
I haven't logged in, but
I can just skip it. So the key to any window is that there is now a drop-down menu called Windows, and that allows you to simply go, okay, which window do I need? I think it was a mistake. They added a function whereby you go in there and it's actually labeled by topic instead of by window category. And the reason I'm saying that is because there are sometimes window tabs that you click on, you think, how are these related at all? So I understand that can be a problem as well. So for the Animator and animation windows, and I do want to stress that there is a significant difference between the two. You can go up to Window, Animation, and then the really useful thing about Unity is that they've assigned, and you can actually do this yourself at any given time, you can very easily create your own menus for the Unity editor and add things like the Command 6 button here. And so what this does is, now that I have the Animation tab open, you can see Animation, Animator, and Animator, what is that? Parameter. Now, if I were to simply push Command 6, or on Windows, Control 6, instead of having to go through all of this, it just pulls up the window right there. So it is, generally speaking, a good idea to try and, if you're going to work with a system a lot, you may want to try and memorize a bunch of these key commands. And then if we open that up again, oh, that's animation. So you go Window, Animation, Animator, and that'll give you this window, which I agree with you guys. A couple of you mentioned that the transitions and things didn't make the most visual sense. I'm inclined to agree. It's been 5 years, and it's still not my favorite system to work with. But it's definitely useful system because it allows you to do state-driven control of animations. And that is definitely something you're going to encounter a lot in the future if you choose to go down this path. In the Flappy Bird demo, which if I can... Sorry about this, I'm not used to using OS X. So in the demo, it only had a couple of states, and we weren't too concerned with actually managing every possible animation. There weren't a lot of keyframes, things like that. If you were to import the standard assets package and the characters sub package with it, and just, you can if you want. I'm not going to recommend this as a learning exercise at the moment, but it's good to see, I think. If you go in there, you pull the Ethan character, which is just the standard character they give you. You look at its animations, and it has thousands of keyframes that all had to be manually inserted. We don't want to be doing that. And again, that feeds back into that IK animation system I was speaking to previously. Now, if I can get the... There we go. Open Unity again. So in my project, if I can get this to open... Yep, that's the right one. Well, apparently it doesn't like the fact that I'm trying to open something from a newer version of Unity, but...
And that's something I can do before fifth period. I can update Unity, or I don't know how long it would take.
It shouldn't take too long. Yeah, no, I can't do that in the current version, but I can walk them through it. So in that, a lot of the questions with the animator stemmed from either having animations not show up at all, or having them show up but improperly, if I'm recalling correctly. So the main issue, just from a few of the descriptions I got, it sounds like the transitions have the exit timer feature still enabled. And that's sort of what I wanted to demonstrate with this, but apparently I am unable to do so. So the has exit time parameter gives you a default time longer than the animation itself for the exit, and will in fact cause the animation or animator as a whole, depending on how it's set up, to terminate functioning. So it is very important to make sure has exit time is turned off for all assets that don't need an exit time. In this case, I believe that's every single one. And that is trickier to find. That you actually have to select the animation in the project window, go to the inspector, find the has exit time setting, and disable it. So that's a little more involved than pushing Command 6. And as a note, and I don't know if this is up on the site, but the Slack channel, I know you guys have been discussing...
So what I'm holding off on that, because right now they're doing a shootout between...
Okay, yeah.
And feel free to offer your very liberal perspective. I don't mean conservative liberal like politics, but game management software, project management software, your opinions, because Trello, Slack...
I have tons of examples. I could pop a couple of those on the screen. Yeah, so I'm actually a big advocate for Trello. A lot of people say the interface is too simple. They don't particularly care for, I can set some colors. But I find it useful because I'm not trying to write out every single minute of every single day. I need to get a few grand concepts done that have some subcategories, check boxes. Now, for some people, that may not be what does the trick. Some people prefer something more, like I said, granular, more... There we go. More, minute to minute. And that's fine. It's different for different people. like I said, I'm more of a, look at the big picture, then deal with the highest order, smaller steps. I'll leave the rest to the notes. So for me, just to demonstrate what I'm talking about, if I can actually log into this website this time, or not. Unfortunately, I just had to change. I don't know if you guys keep up with the latest in hacking news, but there was a massive, the biggest ever password and username breach recently. So I do recommend changing all usernames and passwords. Unfortunately, it tends to lead to things like this. How long ago? Let's see. Well, I don't think that's going to work. Yeah. Well, okay, I would pull that up, but apparently that password doesn't want to work either. So to give a basic outline, if I could use the whiteboard over here.
Yeah, go for it.
Perfect. The way I organize my projects is by having, okay, we do this with Unity. We need this done, let's call 3D art. And we have music, just as examples. So after that, those would each be their own board. They wouldn't just be a card or even a list. They are each their own board under a team. So when I log in, I don't just see, oh, this is what I have to do today for Unity. I can say, okay, this is what I need to get done. These are the other things that are linked to it that I need other people to get done. I can see where they are and communicate with them more effectively if I have that information. Because I can say, hey, I know you need to get X, Y, and Z done, but my department needs this done so that we can move forward. How can we work something out so that we can get this done more effectively? And then on top of that, it also enables me to break things down by team member, and I have my own labeling system for every single card. So we could say underneath Unity that I have, I would have a planned progressing and complete. I tried to think of another word starting with the letter P and didn't come up with one that I liked. So yeah, so underneath each of these you would have, the standard list and your cards. So each of these, for me, represents a major task that needs to be completed. The list it's in, its state of completion. And then it's for the checkboxes. You can get the checkbox menus. Each of those are some minor thing I need to do to make the whole thing work. Generally speaking, I will not include the minor tasks for things like a refactor or repair. It would take me more time to set up the card than it would to actually do what I had to do. So that again gets relegated to my notes. And the other interesting feature about Trello, and this isn't available with every management website I've seen, is you can integrate it directly into your team's Slack. And that has been pivotal on the project projector system I'm working on with Mr. Balakrishnan. So every time someone makes a change, whether it be to due date, tasks to be done, I finished something, things were moved from one category to another, like to complete, it actually sends a message and therefore a notification to every team member involved saying, hey, by the way, something changed and you need to review it. And that has actually done a really good job of keeping people on task, especially across multiple departments.
We've got like 1 minute left
Okay.
for this class. The nice thing is he's going to be here for fifth period as well. And so what we're learning is like what he's presented to you. Fifth period will probably either continue on, like do an overview, and then continue on. But I'm going to recording both sessions and putting them on the blog, then we can highlight things that were covered there that weren't covered here.
Perfect.
So, and the great thing is, we don't want him to be a stranger, and he's done all these great things for us, so we'll be in touch. So.
Definitely, yeah.
Mike, a question? I think if we're polite and invite him in a nice way, I'm sure he would.
Absolutely. I literally live just down the street, so.
Awesome. Let's show him our appreciation.